Hello everyone. Today we're going to learn how to solve equations. Equations are kind of like puzzles. They tell us that two things are equal to each other, and our job is to figure out what the variable x is, usually by isolating. Now there is a common misconception. A lot of people think that when we move terms around in an equation, we're just like magically shifting them to the other side. In reality, we're not really moving anything. We're more so balancing them, and we're doing that by doing the same thing to both sides. It's a rule that whatever you do to one side, you must do to the other side to keep it equal. Now, let's start off with our first example, subtraction and addition. Suppose we need to isolate for x, given this equation, x plus 5 equals 12. Let's first rewrite the equation in the red box. We should understand that we need to isolate for x. How do we do that? Well, we should do something here to get it to equal to 0. To do that, we should minus by 5. However, whatever we do on one side, we must do on the other side. So it's also 12 minus 5. Like we said, 5 minus 5 here will get us 0. So it's really just x. And 12 minus 5 is 7. So we've successfully isolated for the variable x and solved it for 7. Then we have subtraction. It's also asking us to isolate for x, where x minus 3 is equal to 10. Let's rewrite the equation. Now we need to get this area equal to 0. So how do we do that? We add by 3. And negative 3 plus 3 is equal to 0. And whatever we do on one side, we have to do to the other side. So we do 10 plus 3. This gets us x, because negative 3 plus 3 is 0. And 10 plus 3 is 13. So we get x equals 13. Now, let's move on to multiplication and division, where we have this example. In this example, let's first rewrite the equation. And we have to know is that this x here has to be by itself. How do we do that? Well, in order to remove this 3, we can divide it by 3. That's because division is the opposite of multiplication. And whatever we do to one side, we must do to the other side. Therefore, x is equal to 5, since 15 divided by 3 is 5. Here is a division example. And like you might guess, you must multiply to cancel out this 4 here. And whatever you do on one side, you must do to the other side. So it's x over 4 equals 6. We multiply both sides by 4. And then we can get x, because these two cancel out. And it gets us 24, since 6 times 4 is 24. Now let's move on to some more complicated ones where we have like terms. And keep in mind that this is prior knowledge from Unit 2. Let's first do this one. 2x plus 3x equals 15. We can add up these coefficients and keep the x the same. So it's 5x equals 15. And we can divide both sides by 5 to isolate for x, where x equals 3, since 15 divided by 5 equals 3. Here's another one, a little bit more complicated. 4x minus 2x plus 7 is equal to 15. Here, what we should do is simplify this and subtract them, keep the x's the same, and subtract the coefficients to get 2x plus 7 equals 15. And then we need to do this first, because we're really following reverse BEDMAS when we do this. So 2x is equal to 15 minus 7. And keep in mind we also minus 7 here. So this gets us 2x is equal to 8, and x is equal to 4, since we divide both of these by 2. This cancels out the 2's here, and we can simplify this. Now let's move on to something even more complicated, where we have the fractions. This is a common occurrence, and we've seen it a little bit earlier on here, but let's just try it out. Here. Now, again, we're following reverse BEDMAS, so we must minus 3 here, and when we do that, we also minus 3 on the other side. So this gets us x over 2, and 3 minus 3 is 0, and 7 minus 3, which is 4. Then we should multiply both sides by 2 to cancel this out. So 2, that gets us 8, and we can cancel out both of these to get x alone. Here's another example. 3 over 4x minus 2 is equal to 1. Again, we're following reverse BEDMAS. We have to use this. 3 over 4x minus 2 is equal to 1. 3 over 4x minus 2 plus 2 is equal to 1 plus 2. The negative 2 plus 2 cancels out here, becomes 0, and this becomes 3. You can use an arrow to show that we're continuing the problem. And here we can multiply both sides by 4 to cancel this out. So these guys, they go away, and it gets 3x is equal to 12. Again, we divide by 3, which gets rid of these guys. And what we do on one side, we do to the other side. So it's 12 divided by 3, which is 4. Now here are some things that you should try on your own. 2x plus 3 minus x equals 7. And 1 over 2x plus 3 over 4 equals 7 over 4. Try these two out on your own and come back for the solution. Now that you've tried it out, let's try solving it. Here, we have to collect like terms, where 2 minus x is x. Then we keep everything else the same. After that, we should subtract both sides by 3 to get x alone, and then do 7 minus 3, which gets us 4. Then we have a bunch of these fractions followed by each other. This one might seem a bit daunting, but when you see that these two fractions, 3 over 4 and 7 over 4, are like terms, you can see that this is much simpler. Let's just collect the like terms by doing this. We're going to minus 3 over 4 here. And we're going to do the same thing over here. Now what this gets us is 1 over 2x. 3 over 4 minus 3 over 4 is 0. And 7 over 4 minus 3 over 4 is 4 over 4. 4 divided by 4 simplifies to 1. And when we multiply both sides by 2 to get rid of that denominator, we can get x equals 2. Since these guys cancel out, and the 1 stays here with the x. Here is a word problem. Sarah has 5 more than twice a number. If Sarah has 17, what is the number? Okay, now the first thing we should do when solving this word problem is translating it into mathematical terms. So, twice a number. Our number is x in this case. So, let's write that. Twice a number. It's 5 more than twice a number, so we add by 5, and it is 17. It has 17, so it's equal to 17. From here, we can simplify, where 2x plus 5 minus 5 is equal to 17 minus 5. And then 2x, 5 minus 5 is 0, and 17 minus 5 is 12. Then we divide by 2 on both sides, where the 2's cancel out, and it gets us x is equal to 6. There we go. That's our lesson on solving simple equations.